Here we're going to be solving a trig equation. We have sine squared x is our only variable piece in this, so as far as solving for that, I need to add the 3 over and divide by 4. I would end up with our sine squared of x is equal to 3/4, and then I'm going to take the square root of both sides, and so then we would have sine of x is equal to, and that's going to be a plus or minus the square root of 3/4. So I can simplify that. I'll square root the top and the bottom. So that ends up being the sine of x is equal to plus or minus the square root of 3/2. Now we're looking for exact answers here, so we're going to use our unit circle and find where is our sine value equal to the square root of 3/2. So it happens here in the first quadrant. Remember, your sine values are the y values of our coordinates, and so at pi over 3 is our first answer. But then we also have sine equal to the square root of 3/2 here at 2 pi over 3. And as we continue our way around, remember we said plus or minus, so then it also happens here in the third quadrant at 4 pi over 3, and then also here in the fourth quadrant we have negative square root of 3/2 at 5 pi over 3. So we have 4 places around the unit circle, 4 angles that we have found. So we have pi over 3, could also have 2 pi over 3. We can also have 4 pi over 3. And we could also have our angle for x be 5 pi over 3. Now that's just for taking one lap. What we also need to remember is that sine wave goes on forever. So that means every single time I take another lap, every time I go around 2 pi, I find another place where that's an angle that would be equal to either the positive or negative square root of 3/2. So I'm going to add 2 pi to each of these because I could take a lap. In fact, we could take multiple laps, so I don't just add 2 pi, I add 2 pi times n because every single time I take a lap, I get that answer again. So we have all of these possible angles for x. Remember our rules from algebra. Here we're solving for x, and I have x on both sides, so I want to get the x on the same side. So I'm going to add that sine of x over to this side, in which case now I would have 2 of them. 2 sine of x minus the square root of 2 is equal to 0. Solving for that, I'm going to add that square root of 2 over. Also need to divide by 2. So we end up with square root of 2 over 2. And so again, now we're at a spot where we're asking what angle for sine, what angle x would we have where we end up with square root of 2 over 2 for our sine value. So again, looking at that unit circle, in this case, let's talk about degrees instead of radians. That's all right, we can do that. So square root of 2 over 2 for my sine value, as far as being positive, happens at 45 degrees, also over here at 135 degrees. So I have 2 angles where x is equal to a positive square root of 2 over 2. That's at 45 degrees, and then it's also at 135 degrees. And then again, it's every single time we take a lap. So I'm going to add, this time we're talking degrees, so I'm going to say 360 degrees times n, and that'll show us that every single time we take a lap, those are going to be answers where our sine value is equal to square root of 2 over 2. In this equation we have 2 sine squared of x plus 3 sine x plus 1 equals 0. We could think of this as 2x squared plus 3x plus 1 equals 0. This is a quadratic, and anytime we're solving a quadratic, we want to have it set equal to 0, and now we're factoring. So in this case, I'm going to be factoring into 2 quantities here. Our first part, to get 2 sine squared of x, I'm going to have a 2 sine x and then sine of x for my first term in these. That'll give us our 2 sine squared of x. Now our last terms, we get a plus 1 here, so to have a positive middle term means both of these are going to be positive, and to get 1 here, then it's going to be plus 1 on both of them. So now we're going to solve each of these 2 different parts. So we're going to find 2 sine of x plus 1 equals 0, solve that. We're also going to solve sine of x plus 1 equals 0 as 2 separate pieces, just like we would on a quadratic. Here I'll subtract 1 and divide by 2. So we're looking for what angle is sine of x equal to negative 1/2. And here I'm subtracting 1. So we're looking for what angle is sine of x equal to negative 1. Now let's say we're solving this one on the interval from 0 to 2 pi. All right, so if we're solving from 0 to 2 pi, now we're only going around that unit circle one time. And so to find our exact answers, where is sine equal to negative 1/2? That happens at 7 pi over 6 and at 11 pi over 6. And then where is sine of x equal to negative 1? That happens at 3 pi over 2. So on the interval from 0 to 2 pi, we would have those three answers, or those three angles for x. 7 pi over 6, 3 pi over 2, and 11 pi over 6 for our solutions. Example, we have 2 cotangent of x plus cotangent of x times the cosine of x equals 0. And one thing we're going to want to do whenever we're solving any of these, first of all, we're going to need to separate these two. We can only have one of our trigonometric ratios in each piece. So we would need to factor out a cotangent since both of these terms have cotangent. If we can factor out a cotangent and separate these two, then we can solve this. So if I take a cotangent out of here, I have the 2 remaining. Take a cotangent out of this side, we have just the cosine. And now we have these two separate factors. And so then the product of them is equal to 0. We can set each of these equal to 0 and solve. So either the cotangent of x equals 0 or 2 plus the cosine of x equals 0. Well, let's see, in solving this, if I subtract the 2 over, we are saying that the cosine of x is equal to negative 2. And remember, cosine values go from negative 1 to 1. So there are no solutions for that side of our problem. Cotangent of x equals 0. Remember, cotangent is cosine over sine. So if we're saying this is equal to 0, what we're really looking for is where is cosine equal to 0? And that happens at pi over 2 and at 3 pi over 2. So let's say we're still working on the interval from 0 to 2 pi. We have these two angles where that would be true. Last example, we have 2 times the cosine of 2x minus 1 equals 0. Again, we're solving for x. So I'm going to add the 1 and divide by 2, and we have cosine of 2x equals 1/2. And so what we're looking for here is I'm taking the inverse cosine of both sides, and so I'm finding my cosine values that are equal to 1/2 using that on the unit circle. So thing is, this one's different because of the 2x. So what we're saying here is that 2x is equal to that 1/2 value for cosine happens at pi over 3. So if we're talking about all the solutions, we could again add our 2 pi times n. We could also then, because we have another spot on the unit circle where cosine is equal to 1/2, and that would happen at 5 pi over 3. And again, every single time we take a lap, that would still be another solution. Now here we have this equal to 2x, and so we're still solving for x in both of these cases. So what I'm going to do is I'm going to divide both sides by 2 or multiply both sides by 1/2. Thing is, on this side, it's the entire quantity here that gets multiplied by 1/2 when we're solving for x. Because what this ends up doing is it changes our laps. So what we end up with on this side, I take the pi over 3 times 1/2 and I get pi over 6. But I also take half of this, so now we're saying that every single time we take a lap, or half a lap, we're going to get another solution. Same idea then here, when I multiply by the 1/2, I get 5 pi over 6 plus pi times n for all of those solutions.